so today in the mainstream, I wanted to do a little one-off project of basically like using end curses to render like an OpenGL rendered thing. Um, and I think making a like shitty little 3D test case within one stream is going to be too hard if we do it with all that like end curses stuff as well. So for happy hour, I want to like bang out like a shitty little like 3D cube rotation, you know. So like end curses 3D renderer or something. Yeah, so I just want to like bang out something that's like a rotating cube that we can look at and like understand what we're seeing. And I think while I would love to do it all in one shot, I think that it will just take too long. So let's just make our OpenGL test case now, and then we'll be chilling. That's the plan. So we need libgl, ogfw. Probably that's it. Yeah, sure. Let's start here and see what happens. Let's start here and see what happens. So I think let's start looking at some like GFW hello world. We're gonna need a window. We're gonna need a window to show some stuff. We want our typical Zig project setup. So kind of fuck this shit. Delete all these comments that I don't need. Build an executable and nothing else. Okay. And then we do our little return error. Uh-oh. Okay. Zig build, I guess. And uh-oh. Hell yeah. Okay. GFW, hello world. Okay. So they're getting to the point where they can clear a window. Sure. Can we just copy paste from source? Yeah. So we initialize OpenGL or initialize the window or initialize GFW, open the window, then have our main loop. Sure. This is fine. We can start here. And we can adjust. Not hello world, hello's wherever. Hello. All right. I think I need git init here for my ls files thing to work. And I guess I'm down to just paste this time. So we need GFW in here, which comes from like a C import with C include of, what is it? GFW, GFW3? Sure. Okay, init GFW. Sure. Ask for an OpenGL version. Sure. Kind of fuck this shit. Make a window. Sure. 800 by 600. And we'll call this rotating cube. Null and null. Okay. Cool. Looks like there's a check case here where we return error init window. Okay. And they load OpenGL through GLAD. We're not going to do that. We're just going to use OpenGL raw. Like this. We're not going to set this callback either. We'll figure it out. While the window should not close, we clear the screen, sure, and swap buffers and pull events. Okay, cool. How can you see the documentation so fast? I mean, it's because like I know what I want. I'm like just like I'm using this as like a, it's already like internalized. I'm just using this as like a way for me to not have to type it all out and look it all up again. We need OpenGL headers as well. which I think that we have as gl.h. And then, if I remember correctly, you need to define some sort of like special thing to make all of the functions available to us. This. So if we want GL, we say C define this stuff as 1. Okay. So now we should be able to call these. Boom, boom. GL.GL clear and GL dot this. In this language, you don't have like postfix Fs. So we delete them. And this should give us something that works. C import failed, right? Because we have to tell this guy link system library of GLW probably, and probably GL as well, and probably libc. Maybe. Probably. Something like that. GFW init has a return value, which is what? Here. Return true or false, and then ref error handling, but we're probably fine. So if this is equal to glfw false, then we are like return error window or init glw. Okay, does that compile? Expected bool found int. So if this window should close is not equal to 0 is when we close. Probably. All right. I guess it's equals 0. Yeah, there we go. Cool. Window should close equals 0. What the fuck? Window should close. Returns the value of the close flag. Okay, but like, why is it backwards? Like, the fuck? Is true and false first? No, one is true is 1. Am I high? Window should close. Oh yeah, I'm sorry. This is a while loop. While this should not close. Right, of course. I'm just a dumbass. Okay. So we have a window. A window, and we want to do anything OpenGL in here. So is there like... Give me like something that renders a triangle. They define some vertices, they generate some buffers, they bind the buffers, they create a vertex and fragment shader. Sure. Can we look at like just like full code? Full code here. Okay. So OpenGLN, we want to draw a triangle. What do? We upload some vertices for that triangle onto the GPU. We define like the format of those vertices, and then we run a program that like takes those vertices and does something to them, right? So their program says like, give me some vertex and literally just like pass it along. I'm not going to do anything, but this is where like your OpenGL work happens, where you like actually make use of your GPU hardware. This guy says, I'm going to color this thing according to some rules, and they just hard code a constant color, which is perfect for me. That's exactly what I want, because I just want like the world's stupidest thing. Okay, so let's just make this look a little bit more sane. Cool. So there's our world's simplest vertex shader. I'm not a big fan of the word apause here, but whatever, we'll leave it. And I guess this should go in source. Okay, and then the world's simplest fragment shader here. Like this. Okay. Cool. I guess we want to put this guy in here, and let's try to compile some shaders. So what is it? You create some shaders, you check their compile status, and then you link them to a program. So it's kind of like all of this stuff goes into like compile, like make program. Which probably returns like a GL uint. And I think we probably split out like this part into compile shader. And this takes in probably some like source as a null terminated string. Then we make this look more like Zig. So this is our shader. We probably want the shader type as well. So this becomes like, how come I always see you only code in Zig? Because I prefer it. I like it the most right now. And it's simple. This is the shader, and then this guy's going to take in the source code. So this is source pointer and null here. Well, unless this was the size, this is length. Why is it a pointer? I don't understand. That's fine. Well, what is the last parameter of this thing? Length specifies an array of string lengths. Oh, right, because this thing can compile multiple shaders at once. Right, so we just take in, that's fine. That should work. Then we check if we succeeded. Probably glint, I would assume. Shader, like we'll call this buff, is this many U8s. For when something goes wrong, they can yell at us. We can check the compile status. We throw it into the success variable. If this success is not equal 0, equal 0? They said if not success. So yeah, if success equals 0, then we try to print that shit. We like extract that shit. So we say, give me the shader info log from shader with into a buff of this length. What's the third parameter here? Oh, buff size length. Oh, who cares? And put it in this buffer, and then std debug print. I guess we do actually want this length, huh? What is the parameter? It's a size I. Because then we can go, give me, render buff from 0 to len here. Yeah. Yeah. All right, sure. Sure. What's good about Zig? It looks very appealing, but hasn't compared against Rust. It's just kind of like more flexible. I would say that like Rust is to C++ as Zig is to C, is how I describe it. So like Rust kind of takes the approach of like, we're going to make everything, and it's going to be like fucking bulletproof, and it's going to be sick, right? But Zig, and that's kind of like the C++ approach too, right? Like the standard library has like the whole fucking, it's got all sorts of shit in it. The language tries to do all sorts of stuff for you. Zig is way more like, let's modernize C a little bit, give it some generics that don't really suck, and like, but get out of your way. And I kind of feel like I like that better. I like that better right now. What are we coding? I'm trying to make like a simple little like rotating 3D cube demo. So that in the mainstream we can like render a 3D thing in the terminal using OpenGL. This probably has to return the shader. Okay. Then we can compile shader with embed file vert GLSL with GL vertex shader. Okay. And then we get the fragment shader. I guess if this fails, we return error. Shader compilation failed here. And then this compiles the fragment shader like this. that kind of gets this out of the way. Then we create a program. And we bind our two shaders. So we say attach vertex and fragment shader to this guy. Link, please. And then we do the same kind of shit where we check the link status. So if success equals 0, then we do the same shit, but we do it with the program instead. So we like do this thing again. Grab buff len, and we want to know the length, which was GL size I. And then we put this thing in the buffer, and then we do the same print here and return shader link. Program link, I guess. And then cool. I guess we want to delete these shaders if they are kind of unconditionally. Once we create the program, we don't need these anymore. So we kind of do this, delete this shit at the end of the scope. And there we go. We should be able to make a program now. Okay. Let's just hope that this all like compiles. No, because here this can take many sources, so we have to put an ampersand there. And then this guy's mad because he got a const u size, but he wants a constant, so we need to do like len int, I guess, is a c int is equal to source len pointer cast or int cast like this, and then we can pass this guy in here. Okay, is he happy? Nope, because 23 here, this guy needs to be int cast here. And that means the other one does too, this guy. Okay. How long have you been writing in Zig? Probably like coming up on a year at this point. Probably. I'd have to look. We can check. Let's see. We would have started here 10 months ago, yeah. 10 months. But, I mean, Zig was pretty easy to get going in, to be honest. If you've written C, Zig is just, like, if you've written C and C++, Zig just comes naturally. Like, it just makes sense. I don't think it took that long to get up and running, to be honest. All right, so we have our program. It doesn't do anything yet. So we need some data. We need to like render a triangle or something. So which one are we copying from here? So somewhere they define some vertices. That looks like they're using an index buffer. I don't want to do that. So I just won't. But we're copying something along these lines. We'll kind of figure it out as we go. Okay, so what are we doing? To render stuff on the GPU, you need to like take some data, put it on the GPU, and say, please render these things for me, right? So we define a list of triangles here, right? Where we go like, okay, we're gonna like have one triangle who's made up of 3 3D positions, right? So he's gonna be 0.5, 0.50, which means like XY0, XYZ, XYZ. This defines like a triangle. We say we need like a definition of both the data as well as how the data is going to be like interpreted. That's kind of like the way that they do this thing. So it's like, I'm going to put this data raw up on the GPU, right? But how do I know that these are 3 3D vertices? Well, that's the job of like the array buffer, the array object. So there's like var vertex array object. And then there's vertex buffer object is kind of like the way people usually do things. I think that these are like kind of the old style calls for this, but I'm not going to bother fixing that up. So we like create these things. So these gives us like handles to GPU buffer object or GPU objects. or OpenGL abstractions around GPU buffers, I guess. Um, then we bind this thing. So we say like, hey, all of the future like array commands that we do to define like how these things are laid out, um, like this is this object that we are attaching those things to. Then here we're like, let's take the actual buffer, like the actual content, and let's put it up there. So this thing takes size of vertices, which is verts len, I guess, times size of f32. And then we take the content here as well. Cool. They're doing like index buffers, which we're not doing. And then here they're like, here's the format of that data. So what are the arguments here? Index. So this is like here in our vertex shader, we've defined that we want like 3D vector inputs or 3D like position inputs, right? And we've said manually like this is at location 0. So that's what this 0 is here, is saying like for index 0, the 0th item in our vertex shader, this is where this is going. And we're saying like, hey, this has like 3 items, they're of types float, they are not normalized, and this is how far they are apart from each other. So this is size of f32. Fine. And then here it says like you might have like multiple things in here, right? So if you were to attach like color data, you might say like let's throw like RGB in here as well, right? In which case like these positions would be kind of like farther apart from each other, and they would also be offset. So if it was like this, you would say like, okay, there's 6 of these guys, and my RGB are offset by 12, right? But we're not doing that, so we don't have to worry about that right now. So it's just like our offsets are 0, defined as a pointer for some fucking reason, and we're 3 apart. Okay. Uh, you guys are talking about AI apocalypse? Dude, I think I really wouldn't worry about it. Every fucking time I use AI, it pisses me off. It's so stupid. It's only good at like really surface level knowledge. And the farther you push it in any direction, the worse it gets. And maybe that will change in the future, but for now, it's just like I don't know what the fuck everyone is talking about. Like I really don't, because every time I use it, it's just like, what the fuck are you talking about, dude? It's like kind of good as like a first pass search. Kind of. My favorite tech speaker, Andre Alexandre, is that the C++ guy / D guy? Has talks about Gen AI and programming. If you're interested, check out Robots Are Your Job, Exploring Generative AI for C++, CPBCon 2023. All right, I mean, I'll take a look, but it seems pretty stupid. LLM based AI won't be replacing any programmers anytime soon. Yeah, maybe. I mean, it's hard to know, but that's my guess. I'd benefit from using AI here. Yeah, a little bit, but I don't really mind doing it this way either. I don't mind, because really AI would also give me like, okay, so I've tried this before. Actually, for this exact case, I was like, convert this to Zig code for me, and then it shit the bed. And so I'm just like, I don't know, man. Who knows? Read them both together as 2-part. The worst thing I'd ever said to anyone was something I said recently. You'd benefit from using AI. Oh, I see. I see. This is the type of thing, though. This like type of setup is the type of thing that I would expect AI to be able to do for me. It's just like even this, it gets wrong every time. So I just don't bother. Like copy pasting an example is easier. All right. So make val, and then we probably have to like use the program, and we probably want to bind vertex array, and then we probably want to draw some triangles. So I think it's like GL triangles. First is the the 0th triangle, and then we have 3 indexes, maybe 1 triangle. It's either in units of triangles or vertices. I don't remember which. But we'll see. It'll become apparent very quickly. All right, there's a triangle, baby. Okay, cool. Cool. And I guess we can double check here. I'm pretty sure it's in units of vertices, not triangles. Yeah. So we need to do 3 because there's 3 vertices per triangle. Okay. So now let's try to get a little interesting. Let's replace this with a cube. So let's define a cube so that it fits in like the typical OpenGL space. I'm kind of okay with that. So we need something that has like we need like these triangles ish. So I guess we'll start we'll start with the front face. So front face. So we already have this triangle. Then let's do this one. And all of these guys, I mean, if we're trying to say that this is negative 0.5 in z and this is 0.5 in z, I'm assuming that we want forward z depth. Maybe we want negative. We'll find out later. So we can do negative 0.5 on all of these guys. Okay. Now we can do the top left face, which is going to have 2 of the same vertices, negative, negative, and positive, positive. We should make sure we have winding order correct too. I think I want clockwise winding, probably. I'm used to clockwise winding, so is that what they're doing? They have top right, bottom right. Yes, they are doing clockwise. So now we want to do top right, bottom left, and start with top left. So that's this. Then we need to define that we have the right amount of shit. So when we draw our triangles, we need to draw, now we have 2 of them. Okay, cool. Cool. Now, I guess we have to do, let's do the top one next. So he's going to share my poor little brain. We're changing z now, I guess. So we take like the bottom right triangle here and we say, let's use that. But only one of these vertices is right. It's the top right one is correct. Then we need something that is here. Which is... Dude, why is this so hard for me? This is positive y, negative x, negative z. Positive y, negative x, negative z. Okay. And then if we want this to go clockwise, do we get this one next? Which is positive x, positive y, positive z, I think. And then this guy is this really the best way to do this? This feels so fucking stupid. But whatever. Yeah, do I really want to do this like for every single fucking face? Gen cube verts. Surely this is easier to do like in code. So we say which, I mean, every single one of these faces is the same. It's just like a perspective shift. Is it really easier to do it with math? Maybe it's just easier to do it with like Blender and then copy paste. That's probably easier. Probably the easiest way. So let's I don't know. Copy, paste, paste. Okay. I think this is right. No, we want it bigger. 2, 2, 2. Okay. Then can we just like fucking iterate these? I guess I kind of want to just like export this cube. uh, because I don't like. Is this really easier than than defining every triangle? Maybe, maybe. Let's see. Oh yeah, baby. So here he's defined these, and then these are the indexes that it's using. Why are there four? Because each one of these is a face defined by Can I configure this just like dump the vertices directly? Um oh, triangulated mesh. That should help. Okay, there we go. This makes more sense. So there now here are this is probably like vertex, normal, and texture, probably. Okay, so let's use index buffers and then we can just copy paste. Then I don't have to think. Then I don't have to think. So we can go back to their example and they used an index buffer. Uh-huh. Okay. So then all you have to do is this guy where we like define the index buffer like this. Is indices, what type do they have? Unsigned int. Okay. So now we can do something like probably U32. Yep. Um Bump 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 bump. So I guess we want to let's just use their example first. And then we can do indices len times size of u32, indices pointer, and gl dot. Okay. So now we just need to make sure. Did we bind the EBO? We did. And then we can unbind. Uh, unbind this thing after, I think. Okay, so then we need to use GL draw elements here, which says basically like if you will have like a set of vertices, which are these guys, right? They're like we have 4 vertices, but we want to use 2 triangles, so we're going to use vertices 0, 1, and 3, then 1, 2, and 3. That's kind of what this is saying. It's a way to like add some indirection here. So what is it? GL draw elements. They want the count mode count. Oh, yeah, mode count type indices. Right. So they want to know the type of the index. So we're drawing six indices of type unsigned int. And then can we use null here? Yeah, okay, okay. So do we still get a square here? We do, which is hype. Okay, so now we should be able to just copy paste our square, our cube out from this guy. So these are our vertices. Like this. We want to add some commas. Here, 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 here. It'd be nice if these were aligned, huh? I guess. I don't know, man. I don't know, man. It doesn't really matter. There you go. Good enough. Good enough. Okay, and then down here, wherever the fuck this guy was, we have our triangles. So here we say take the first thing from each of these. And I guess this is something that could be macroed. Okay. Except some of these guys are double digits. So we need to be a little bit more careful about this. Okay, there we go. Sure. Then we just need to make sure that we get the right amount of these. This is, how many is this? 3 times 12 probably? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, 3 times 12 is 24. Okay, so it's hard to tell if this is right. Because we're only seeing like the front face. But we'll assume that it's right for now. Okay. All right. So I guess what I want now is to add some perspective. Which means that we have to do some sort of like, we can probably hard code perspective in the vertex shader, probably. I don't think we're going to be worrying about changing perspective at all. So we can just like go in here and go like, what is it? OpenGL, like 3D pipeline Wikipedia is where I usually steal this thing from. And last time we did this, we really fucked it. We spent a long time getting confused because we had the row and column major order of this thing incorrect. But now we know. So this is a, if I remember correctly, column major. And I usually expect row major. OpenGL matrices are column major. And we can check this pretty easily. So, do I have like NumPy? No. Okay. Python 3 packages NumPy. 3 times 12 is 24. Yeah, I don't know why I wrote 24 there, huh? It's a pretty good point. Pretty good point. We'll come back to that. Okay. So, if we are constructing this guy, so we have like, I guess let's like, can we define a function? Maybe this is easier to do in a script. Make perspective. Okay. So we take in like width here. Oh, this is orthogonal projection. I want this one. So what are W and H here? H is cotangent field of view over 20. Oh, I always fucking struggle with this one too. What the fuck is cotangent again? Cotangent. Length of side adjacent to angle A, length of side opposite to angle A. Oh, is this just opposite over adjacent? Is that all it is? So here they're saying H is what's the difference between like atan and cotan? Am I stupid? Are they different or are they the same? I always get confused by this. Inverses of sine, cosine, and tangent. Right. So then why do we call it atan? Several notations for the inverse trigonometric functions exist. The most common convention is to name inverse trigonometric using the arc prefix. So they're the same. A10 is arctangent, very different. Am I fucking confused? Oh, inverses versus. No, wait, yeah. Inverse? Oh, no, I see. These are not inverse. I see, I'm a dumbass. Um. So what the fuck is it? Like, what the fuck is this thing? That's that. Ah, sure, okay. And then A10 is something else. I see. I see. So this is just like. I see. So is this 1 over? Oh, every time, dude. Cotan is 1 over 10. Okay, that makes more sense. That is what I was seeing there. God damn it. Okay, so H is 1 over tangent fields of view over 2. Sure. I don't like that we need a name for this. It just like confuses me every fucking time. Jesus Christ. Okay. So I guess we have like FOV here. And near and far. So import math 1 over math 10. Let's say we're going to do 90 degrees. I guess it doesn't matter here. So then we can make our little numpy array from this. So it's 0, 0, 0. Yeah. Boom. Okay, and then they have far over near minus far. And -1. And then near times far over near minus far. Okay, and I expect this to be inverted. So I think it's dot t to transpose it. I think. So like let's say that like near is 0 0.01 and far is like 100 or something. We should be able to say we take this perspective matrix and multiply it by something that's at the near plane. So I think it's like 0, 0, 0 0.001, 1. And then this has to be transposed as well to make this column a column vector. Yeah. Let me print this. So this gives us, then can we do, res is this, res dot 0 to 3, I think, is that how you do this? I don't remember how to fucking use this language. Yeah, and then we divide this by res 4 or res 3. So this gives us 2, which is not what I expected. What if I don't invert this? This gives us 0. 1. Oh, no, wait. What do I expect here? I expect that, like, at the nearest point, I get -1. At the farthest point, I get 1. That's kind of what I'm expecting here. So this gives me 100. That's not good. What if I... Okay, so this gives me 1 if I invert this matrix. And if I pass in 0.01, which is the near point, I get 2, which does not seem right. They might be expecting negatives here? No. This is, like, why am I lost? Far over near minus far, near times far over near minus far. What is at in Python? I think it's like a, multiply by, like, matrix multiplication rules. I feel like this is where I got fucking confused last time, too. Where this thing just did not behave the way I expect. -1 here. And this is 100? Yeah, what the fuck? Like, I don't feel like I'm doing anything crazy here. Far over near minus far. Near times far over near minus far. -1 here. I mean, I could be wrong about what, like, the dot t does. Let's double check this. So, yeah, that seems right. That seems right to some extent. So how the fuck... So I punch in 100 here, I get 1 in Z, which makes sense. It's the 0.01 here that's not behaving the way I expect. That's giving me 2, which means that, like, this is supposed to be positive? No. Oh, every time, man. Every time. Smallest distance to be visible, far the longest distance to be visible. I swear we had this same exact fucking problem last time. And we got confused by the inversion. Okay, but I guess we just have to fucking think about it. So what's supposed to be happening here is that, like, we're dividing by Z, right? So that's what, like, this -1 parameter here is supposed to be, like, divide by Z. Put the Z component as, like, the last component of the array. Which means that, like, we want to make it so that when we are at 100, when we're at the far location, we get 1.0. Oh, maybe this is supposed to map 0 to 1, not -1 to 1. Yeah, that might be it. I might have been confused about, like, what the mappings are supposed to be. Okay, so let's look at this again. So say we want this to be 0. We want to do something where we take far, we're going to divide by far. All this stuff is going to be multiplied by far. So we're going to get, like, far squared here. We're subtracting the near value. I feel like one of these should be inverted. Because we want it to be, like, the first one of the matrix is W instead of H. This doesn't matter. That doesn't matter. I know. This is, like, width versus height aspect ratio. It's these 3 parameters that are important. Can we just look at what the fuck we did last time? Where have we done this before? Wayland client here. Surely we have some like matrix like perspective in this one. We did. What the fuck is this? Here we did infinite projection. And we linked this. Okay. So this is right and left, top, mouse, bottom. So there's some sort of like offset here that we probably don't care about because we're going to stay centered. This feels more like... Okay, so if we plug in... And then he had infinite perspective here. I mean, we can try that. We can try that. I just don't understand why this, like, I struggle with this every fucking time. Probably because I'm, like, using a garbage input. Where the fuck am I? So this is -1. -2 times near, and then this is... -1, -2 times near. Then this is -1. Okay. I guess we want... Yeah, so all we care about here is that near is equal to 0. Oopsies. Which... Oh, oops. Am I fucking high? -1, -2 times n. I punch in a near here of 0.01. So shouldn't I expect... Here I'm getting negative near plus -2 times near. So this is 3 near, which doesn't make sense. What about this way? Also doesn't make sense. Dude, I'm fucking high. I feel like I'm fucking high. Oh, I really didn't fucking want to waste all my time on this shit again. Symmetric infinite perspective matrix. Yes, this is basically what we have, right? 0, 0, 0, 0, 0, 0, 0, 0, -1, -2n. And is this row column or matrix? Okay. If we want this to go to 0... Oh, is this mapping -1 to 1? So we plug in near here. Then... So if we plug in near here, we're getting negative near time plus -2 times near. So this is -3 near. Then we divide this by near? So how could this possibly be something reasonable? How could it possibly be reasonable? Unless it's the other way, which it might be. What if we invert this? Then we get... negative near minus 1 over -2 times near. which gives us nears cancel out. So that gives us 1 over -2, which is what we got here, which again, just like, why? Neither of those make sense. I believe the translation here doesn't do anything. Oh yeah, I mean, needs to be reshaped. Oh, really? Yeah, I guess you're right. So how do you do this again? It's like, yeah, let's try that. Okay. What if we plug a negative here? Ah! Wait. Okay, wait. That's what they're expecting. So they're expecting negative depth here, which is why these are all inverted. Okay, okay. Sure. So if they're expecting negative depth and I wanted positive depth, I invert these. There we go. So that's -1. This is big number close to 1. And as I increment this, it gets closer and closer to 1. Okay, there we go. There we go. Cool. Jesus, that took a while. Okay. So now this is our perspective matrix in OpenGL land. But this has to be inverted because they are column major. So it's like we take column 1, column 2, column 3, and column 4. Okay, like this. Okay, and then we just define these. So 0.01 and -0.5. Why are these negative? I don't really want them to be. 0.5. There we go. There we go. Okay, so now we can multiply this by perspective. Now we've probably fucked this up in some way. uh, we need to move everything back a little bit. Because, okay, that's done something. And then, well, like you said, we didn't finish the cube earlier. So, fuck. Fuck me. So, now how do we resolve this? Okay, just to be like really annoying. I'm pretty goddamn sure I was right before, but yeah, okay. This way made more sense. It could also be that my depth testing is wrong, and maybe I have to enable depth testing. Um. Okay, so we need to enable depth testing, and then we need to set the depth function and clear the depth buffer as well. So if we want to say that we're expecting bigger numbers to be more far away from us, which is what I expect, we can set the depth function here. So passes if the incoming depth value is less than the stored depth value. So that seems reasonable. And then here we should also clear depth with something really big. Something like that. Okay, that didn't really change anything. And then let's just double check here. If I set this to 0, we should see nothing drawn. Good. Okay, so that means that our depth thing looks right. It's possible that our... Oh, all of these indices are off by 1. I forgot. In the object format, everything is offset by 1. I think there's a Vim thing to decrement. Yeah, there is. Okay. So can we just go in here and say, like, decrement everything? No. But we can decrement a column at a time. Okay. There we go. There we go. Okay. And now I guess we want to, like, move the camera around to see if we can, like, identify anything happening. Why OpenGL 4.6? I think that's the latest. I highly recommend using the Zinc OpenGL drivers when using debugging OpenGL applications. What the fuck is that? Why? What's the benefit? If it's Vulkan API calls instead of using target, this can be used to get full desktop. I mean, this doesn't seem relevant. Better error messages. I see. I see. Alright, we'll keep it in mind for the future. Okay. So I think we want to say that we have some uniform that's like camera. I guess we'll just call it camera. Where's the camera? And then we like apply the camera movement, then perspective. And so then we should be able to like uniform for matrix 4 floating point values. That sounds right. So if we want to move this guy to the right, for example, we can do that. So we have some location, which GL get uniform location from program with name of camera. Okay, so this is the camera uniform here. Are you using Glad? No, I'm just using like the built-in OpenGL things. If you like just define GLX prototypes here, then like you don't need anything, is my understanding. Okay. So we say go apply some uniform here. How many of these things are? It's probably one. Matrix for V matrix. So count. For the matrix command specifies the number of matrices that are to be modified. So yeah, one. And let's transpose so I don't have to think about it. Then we have the actual values. So camera matrix. Okay. Camera. Okay, so now we're into matrix. Which is going to be 16 F32s, and we can just define one of these manually for now. It's like this actually in this language. And let's first start with identity. Just to try to make sure that this all works. This probably needs to be a pointer, like a pointer like this. Okay, so that's chill. And if we want to move this thing over to the right now, we can do this and see if we notice anything happening. Nice. Okay, so that's good. That means that the camera matrix is in fact being applied. And I guess, can we do some sort of like rotation? So, apply rotation. Given this matrix. Sure. And by some amount. And so what is this again? It's like if you are rotating around Z, you're like readjusting your axes, right? So you're saying like this rotation, it's by this angle, we get sine theta is your new. Okay, so this was y 1.0. Y is now moving to negative sine theta on x and cos theta on y. Then your new x is cos theta with positive sine theta on y. Yep. Okay, so that's around z. So depending on the axis. So we're applying, let's say we're applying z rotation. We look at, we calculate these. And cosine. And then we set the appropriate guys. So we set the top left one to this, the top right one to this. Then we go down by 4. So this is the bottom left and bottom right. Yeah. And I guess we'll just say set Z rotation. We're not going to do any like matrix multiplication right now. If we just rotate on one axis, then this works. I don't really want to implement matrix multiplication right now if we can avoid it. So like if we do this, what do we call this? Set Z rotation. That seems kind of right to me. Yeah, that feels like it's rotating. Also, this window needs to be square because we're not applying any aspect ratio correction right now. Okay. Cool. So I guess if we want to do composition of these things, we do have to implement matrix multiplication. We do have to do that. Fine. So this is going to give us, I guess, a new... Maybe it's fine to do, like, this. So if we want to do this, it's what you do. You have one of these guys and you put them here, and you have one of these guys and you put them here, and then the thing in here is like this times this. And I can't remember which one goes first. I guess if we know that we have like matrix and vector gets multiplied this way. Which means that this guy's here. Yes. Which means that this guy's on the right. Yes. Okay. So, what are you working on today during the happy hours? We're trying to make like a rotating cube demo so that when we work on render it, like doing like a 3D renderer in the terminal, that it just kind of like everything, we have like an example that we can work with. Okay. So for row, I guess we iterate over each element of the output. Okay. Ret index. Our row is going to be ret index over 4, and the column is mod 4. Yes. Then we go like, we take row from A, like input index, and we look at like A at row times 4 plus in index times the column. So this is the column comes from B, and now the input index is which column we're at. No, the input index is which row we're at. So it's in idx times 4 plus call. Yes. So if we initialize this to all zeros, then we should be able to just say that like ret at ret index plus equals this. And I think that does the right thing. I think. So this should go like, we have a constant row in A, and column is changing. We have a constant column in B, row is changing. That seems right. And we can even do just like a quick test here. If we go back to, am I an idiot using C++? I'm using Zig, which is similar to C++ in a lot of ways. Okay, so if we go in here and we just have like, can we do like, how do you get like a, is it a range to get like a sequential list of numbers in this language? Return evenly spaced values within it. Yeah, so we just go like, so give me like 16 numbers. Is that what this does? Yeah, and then we reshape this to be 4x4. Is that right? Yeah, nice. So we do A is this, and then B is like, I don't know, this plus 1. I don't care. And then we print a B, and then a matmul from B. Okay. And then we can use this as our test case. Oops. Okay. So this is 16 F32s equals this. Boom, boom. Okay. Then we have B. Okay, so we delete these, we get some commas. And one more. Const expected is this. Throw some commas in here. Hello, commas, commas, commas. All right. Then we do ret mat mul ab, and then for 0 to 16, we do like some sort of like try stood testing expect all approximately equal from expected I and ret I within some sort of reasonable tolerance. And he's mad because matmul didn't return ret. Cool. We are getting the right thing. And then just to confirm, if we did this backwards and we did like in index in A, if we got this backwards, we should get the wrong number. Yeah, he's mad. Okay, cool. Cool. So now we can define some like we can do like y rotation as well now. So our y rotation changes x and z, so this becomes 2 and this becomes 6. No, these guys. So before we had the rotation was these 4. Now we want this one, this one, this one, and this one. So we also have to move down. Which means that this is 0, 4, 8, and 10. Cool. And so maybe it makes sense to be like make z rotation that takes in nothing and returns a 16 F32. And we go like make identity, or maybe even like identity is just a constant here. Sure. I guess we don't even need decimals. It figures it out. And then now we can return matrix. Okay. Cool. Make y rotation is going to be the same thing here. Okay. So now we can do something that's like matmul some like y rotation and some z rotation. Sure. I don't know, man. So we do like a Y, then a Z rotation. I don't know, man. And then we matmul that with a translation. Just to see. Sure. I think you're off by like 90 degrees in your Z rotation, which would not be detectable for a cube. The traditional order is cosine, negative sine, sine. Why am I off? Am I fucking stupid? New x. So my. Oh yeah, I am flipped, huh? Because this is. If I rotated, my new x is here. My new y is here, which are the columns, not the rows. Yes. Yep, you're right, you're right. You're right. I did get it backwards. So this is yeah. Cosine x, and then this is sine x. This is negative sine x, and this is cosine x, which lines up with what you said. Thank you. I should have checked this one. I thought I had it. Now the question is this reasonable? I would be expecting to see stuff here unless we're like in the near clip. Right, because we want to move the camera back as well, which we were doing before in here. But we don't want to do it there anymore. So now we're like inside the cube, right? That's no bueno. And so now we need to move the camera kind of back. So here, can we just make this like -5 or something? Like, let's get us like way out here. No, he doesn't like that. He wanted +5? Because is the camera looking backwards? Let me think for a second. Do we want to do the translation first? I think maybe. Because then we're like rotating around the thing. We're taking the vertices, we're doing some manipulation to them. So we rotate them, then we move them. Oh yeah, if we move them backwards, they're going behind the camera. So we need to move them forwards to get in front of the camera. Okay, that makes sense. That makes sense. Cool. So that's looking a little bit like a rotated cube, if I do say so myself. If I do say so myself. Now, can we make it so that the cube rotates every frame? Right? So I think we'll keep the camera in a steady location, but we're going to adjust maybe like only its Y rotation here. Okay, so maybe we do something like now is this, and last is now as well. Okay. Then here we're gonna say our delta, I guess we defer last equals now. And then we say our delta is now since last. and this is in nanoseconds, so let's get it in seconds so that we can, think about it. Delta divide equals like stood time nanoseconds per second. Yeah, nice. And this has to be float from int here probably. Then we can do like our Z rotation, our Y rotation. I think I want like an X rotation on top of this. I kind of want this like kind of cornered cube to be rotating this way in my screen. Which is, oh no, that's a Z rotation. No. That's a Y rotation. Yes. So I want the Y rotation to happen after, I think. And then if we just kind of like increment this Y rotation over time. So var y rot is equal to 0.5, right? This is a float. We say y rot is, plus equals delta times some amount. So if we want like one rotation per second, we do take 1 second times 2 times pi. And then if it's less, delta will be less than that, and so this will get smaller. And then here we probably want to fmod this thing as well. 2 times stood math pi or something? Is that how this works? I don't know. Stood math fmod mod f. Here we go. Why is this only a single thing? I don't really know. I'll just say if y rotation is greater than 2 times math.pi minus. Because I'm not convinced. I'm not confident. Percent? I don't think percent works on floats. I could be wrong. I didn't think it did, but if it does, then that's my bad. There we go, baby! We fucking finally got there. Okay. A little fast. A little fast. So let's slow this down. So maybe 0.25. All right. Let's make it a little bit bigger. So we can get a little bit closer to it. Way too close. Too close. 1.3. Fine. Okay, now what I want, it looks so weird. What causes that? Too close of a near plane? No, the near plane doesn't change the, like, warping. It's like... Is it that there's something different about, like... zooming versus FOV change? It seems like it should all be the same. It has to all be the same. Because the only way you can... no, I guess if I, like, move my eyes closer... Right, this is getting closer versus FOV. So I want to be farther away and more zoomed in. Yes. Which means that I need these perspective numbers to be... If the FOV decreases, my FOV comes from like this to like this. That means that in OpenGL land, like a smaller distance is getting pushed into the range of like -1 to 1. Like the real range of -1 to 1 is getting smaller, which means that these numbers need to grow. Yeah, so we want to be farther back and zoomed in. So let's stay at like 2.0, and then we increase these numbers, which we could have also rationalized by just saying bigger things are bigger. Right? So we're like, get fucking big, boy. Yeah, that looks way more normal. Way more normal. Okay. Okay. Now, what I want to do is I want to add some sort of like lighting to this thing. Because I think that just makes it like nicer to look at. So can we maybe what's the play here? What's the play? We add normal vectors to all of our vertices. Okay. Which means that just copy pasting this guy is no longer sufficient. Because, yeah, we have like, this guy did have normal vectors associated with these things, and he did attach them here. But I don't know if in OpenGL it's easy to like have a split normal and index buffer. I know that you can like get attributes from different buffers. It's like doable. But not trivial. Because you have to use these like, okay. So it's like something like in OpenGL land. Bosco, thanks for the tier 1. Much appreciated. Oh, also, Kirio92, thanks. I missed your sub as well. In OpenGL land, you have like vertex array object. VAO. And this is kind of like the highest level definition of like the data layout in your 3D world, right? So you have these things, vertex buffer objects as well, where this guy's just like data, right? He's got like some like random shit in a buffer, right? Your vertex array object says, okay, I'm going to like bind this vertex buffer, and this thing I'm going to say like, chunks of 3 floats. Chunks of 3 floats, right? And then he might also say like, is XYZ, and then he'll go like, we'll have 3 more floats for RGB, and then like 3 more floats for like the normal, where the normal is just like a line that points away from the face, which is useful in some ways. But this is kind of a lie, this part here. It's kind of more like, if I remember correctly, that this guy points to like slots, and these slots point to vertex buffers, and then these definitions point to slots, or something like that. So you can have like multiple buffers that have different, like you can spread out your data, I guess. So we could like copy paste these normals. But I think I'd rather not. Is there a way to like easily define this so that we, because like now the problem is, we've defined like these vertices like this, right? We've defined like, how many of these are there? 12, 16 or something? 1, 2, 3, 4, 5, 6, 7, 8. Oh, 8. My bad. It's 8. So, but like the normal for this face and this face are different, but they share the same vertex. RCR students is saying using separate buffers is easy, but they're still indexed by the same index when doing index rendering, so they need to be the same size, etc. Is it easy with this style? I was under the impression, Oh, do I just bind a different buffer before calling GL attribute pointer? Oh, it might be that easy. It might be that easy. Can I just say like a I want to bind a second buffer for normals. How would I adapt this code? Let's just see if he says something sane. And he does just say do that. Okay, if that's trivial, then we'll just do it that way. Didn't want to interrupt you. The thing you were looking at paint is important. Yeah. So the reason that like we can't just attach normals to these vertices is like the normal is part of two triangles, and so if you were to just like average these things and kind of point this out like this, you would get like what is called like smooth shading, right? Where when you render each triangle, you would kind of like interpolate between them, like where each of the normals were pointing. So if I go in here and I say like shade smooth, that's what makes it look like this. But I want like flat shading, which says like each of these surfaces is like directly lined up. And so we need all of our normals for all three of our vertices to like agree that we're pointing outwards, right? Which means that we need like two normals for each, maybe like three normals for each vertex, right? For depending on which face he's looking at. But it does seem like it's easy to do. Okay. But then maybe split buffers doesn't help us here? No, it does. It does because this export of the cube that we got from Blender, this guy is in fact matching position vertices to like normal vertices. But can we use split index buffers like that? Maybe we can't. So we can bind multiple buffers and like, but the index buffer still I don't think you can do. Can you use like multiple index buffers at once? What if I want to use like index the two buffers independently? E.g., normals and positions are stored separately and need to be mixed and matched. I'm assuming that's not okay. Like, is he gonna do something stupid here? I mean, he's still got only one element buffer. I don't think that's possible. I don't think. Which means that what we should do is maybe we take the normals. Maybe we just like rebuild like the thing that we want. So this can be the normals. Okay. Can we do something that's like, there we go, add our commas. And then we need to basically like pair our, this is like position indices. And then we have normal indices, which we copy from the cube export. And I assume this is just the second one, but we should probably check that. OBG for like file format. Face elements. It's the third one, so good thing I checked because I would have guessed wrong. Okay, so let's delete these. Level hoodie. Thanks. I bought it myself. So delete word. Go again. This makes sense when you see these like this, right? They're saying like, of course, the normals for all three vertices in a triangle are going to be the same, right? That makes sense. So if we want to rebuild something, we know that our like final buffer, like combined buffer, is going to be he's gonna have some amount of floats, and it's going to be like however many elements are in these times 2. So this is 3 times 12, 36 times 2 is, I don't have to do that math. 72 though. Yeah, so we have 72 of these things. And if we want to like kind of merge the data together, I think that we're going to put the like we're going to like pack the data so that it's like x, y, z, and then like n, x, n, y, n, z. So like first we'll get like the position of the vertex, then it's normal. And so in order to do that, I think we go 4, 0, 4, 0, normal indices dot len. We are going to take the vertex and the normal position. So I guess we can actually just pack these things together. We can say that we have vert position indices and normal indices. We take these things together. V index and index. Then we look at verts at, we need to take 3 elements out of each of these guys, I think. Yeah, because this guy has maximum 6. 1, 2, 3, 4, 5, 6. Yeah, so these are working in units of 3s. So we need to take, we need like combined buffer index is a usize here. So we're going to take 0 is, I guess we have the vert is verts at vert index times 3 to vert index plus 1 times 3, I think. Zik has a built-in zip. That's cool. Yeah, pretty good. Good, huh? And then the normal is just the same thing, but from the normal index. And then now we should just be able to be like combined buffer index. We take vert 0. I'm sure there's a better way to do this. But we take the vertex, and then we get 4, 5, 6, and we get those from norm. And then this has to be, these all have to be offset by combined buffer index. And then we need to do combined buffer index plus equals 6. And then we should be able to upload, fuck this index buffer now. So here we just use the combined buffer. Here we now should have our stride of this thing is going to be 6 now because these elements are going to be 6 apart, but there are still 3 of them. Fuck the element buffer everywhere. And then we're going to go back to GL draw triangles. And we're going to draw, I don't know. We had 36 verts? 36, right? It's like however long this thing is. 3 times 12 is 36. Yeah, so it should be 36. But it was 3 for one triangle. I don't know. Wait, no, we have 12 triangles. We have 12 triangles, so it was 36, not 36 times 3. Okay. And then what's this guy bitching about? Cannot assign to constant. Fine. GL, oh, it's draw arrays, not draw triangles. This is mad because out of bounds at 119, which means that we did this calculation wrong. Because there are 36 indexes, but times 3 times 2. Normals at number, oh, because these all have to be subtracted by 1 now. Right? Then this guy's still not happy? Am I stupid? So we're going over each. Even off by 1 of the latter half of combined buffer end indexing. 0, 1, 2. Oh, yeah. Good eye. Good eye. Good eye. Okay, so we're back and this thing is still working, but we've packed in this like normal data now, right? So what we should be able to do is if we just color this thing according to the normal, that should give us a pretty big clue for if this is working correctly, right? So we can go in here and we can say like, here is our normal position, and we're gonna say that we're gonna pass on our normal to the fragment shader. So this is gonna be just, I guess, norm. And then our fragment shader needs to use that thing. So we're going to say like we have some sort of input, and we're going to use that here. Which he doesn't like. Because I probably did something fucking stupid, like just typed an extra letter in there. That's not good, but we also didn't set that up in our vertex array. So when we like construct this thing now, we now have to be like, okay, so now we also have this thing at index 1. And there's still 3 floats, and they're still 6 apart from each other, but they start at offset 12. They start at like 3 floats in. Right, so this is pretty good here. We can see that like some of these guys are pointing up, right? And some of them are pointing away. Like we see like a constant color for these guys, and then all the black ones are just like because they're like negative values, right? Cool. So now what? If we want to add like lighting to this, you do something that's like, it's like things that are pointing towards the sun, they're very bright. And if they are pointing perpendicular to the sun, not bright. So like this is like not lit, right? Not lit, lit. And so anything in between, you know, like this, I guess like drawing on this side makes more sense because the sun's really far away, so it's effectively like coming in parallel. Like, I think the idea here is that if your thing is angled like this, it gets like proportionally less bright. Oh, it's hard to draw. Okay, let's draw the sun as a bunch of arrows that are coming in parallel. Right? The sun's coming in like this. So if we're like this, super fucking bright, right? And if we're like this, we're like less bright. We're still like a little bit bright, but not a lot bright. And then here we're like 0 bright. And then if we're facing this way, then we're like also not bright. I think that's the idea. So you want to do something like define like a light direction and strength. And you want to like dot product that with the normal, right? And you want to like probably do like dot product with the inverse normal. Yeah. And you want to do this in like world space. So you want to take like, let's think about this. So we're like in this thing, this guy is spinning. And I guess we want we want to act like the cube itself is spinning, not the camera. I think that's kind of what I want to look at right now. So instead of calling like that, kind of means that calling this single thing camera is not ideal, I don't think, because it means that we want the light transformations to happen like after the rotation but before the camera movement. But the camera movement is only a translation, so it doesn't technically matter. Yeah. So we're cheating here? We can cheat here, and that's fine. So then what? We take the normal, and I think we just do the rotation part of the movement matrix here. I think, right? Like your normal, like sun really far away, so always coming constant angle. And so no matter how I move this thing, the brightness of each face is exactly the same. If we had like a point light source, this wouldn't work. But since we're assuming the sun, then I think it does work. And so I think all we have to do is we have to take like the rotation component of our camera matrix here. And I mean, we can call this like, we'll pretend that the camera is stable. How about that? We'll say that the camera lives in a stable location, and this is the like world transform or something. Like how this object is being manipulated in the world. World transform uniform. Yeah. And then if we just say that the camera's sitting in the middle of the world and will never move, then that kind of solves that. Obj matrix. Sure. So then, now that we've called it that, we just have to take that component of it and apply that to the normal. So can we like extract a 3x3 from a 4x4 matrix in GLSL? Does the sun move? Does it exist even? We're gonna make it exist. So if I just do mat3, does this give me the return up to 3x3? Hell yeah. So we can literally just do like mat3 world transform times this. Fuck. We fucked something up. It's because this is world transform uniform. Dumbass. Okay, so that's kind of sick, right? We are now seeing that as this guy rotates, the part that's pointing right is getting like progressively more orange, right? So that means that the normal is in fact like now relative to the world staying the same. Yeah, that's pretty sick. Okay, so now if we define the sun, I guess that probably goes in the fragment shader. So we want like some vec3 uniform vec3 sunder, right? And then we probably also want sun strength. And we take like our normal and we dot product it. So we need to make sure we know that this is normalized, which means that we can just do the dot product without any like consideration for scaling. And we want to say like, I think we take the negative, right? Because like the dot product is like 1.0 if they like fully align, negative 1.0 if they're like fully opposite, and like kind of like a linear projection otherwise, right? So it's like this this value is the dot product. So taking the negative should tell me if they're opposite from each other, and then we take like this times the sun strength. Strength. Yeah, okay. And then this thing we need to clamp from 0 to 1 so that if it's negative, it like, solves itself. I guess we could do also like the maximum of this and 0. Yep. So this is like, then we probably also want to multiply this by the color. So if we make like a red cube, we can multiply, we can say that this is the like face sun color is sun amount or something. This is a float, right? Yeah. We multiply this by the color and then we add some sort of like ambient lighting. So ambient lighting is just kind of like shit's always a little bit lit, right? So we're gonna do like, I guess we have some sort of like ambient amount as well, right? And then we take like the color times the ambient strength plus, I guess it's literally like ambient strength plus face sun amount, like this. So I think it's like this. And then let's this is 0.1, this is 0.3 or something. I guess this can be up to 0.9 to make it so that we get like the full color. And then this guy, we can just define him as like, we probably want him coming like down and to the left. So can we just like take like, we have Z's going into the page. So can we just do like, I don't know, something that's just like on an angle? -1, -1, -1. And can we like normalize this? Does this give me what I want? Norm? Lionel G? That sounds familiar. Nope, that's not what I want. NumPy divide by length. I'm sure. This is so stupid. I should know this. In NumPy, how do I normalize a vector such that its length is 1? Please, sir. Oh, norm gives us the length. Sure. Fine. Fine. I know this is something that I could do by hand, right? But now I'm committed. I wanted the fast way. This makes way more sense. Okay, so sunder vec3, this thing. All right. Tell me that's not sick. I think we want it to be going into the screen so that the side closest to us is lit. That's so cool. Right? That's so sick. Oh, fuck. Okay, every time I think that I just like need to build like there's something about this. This should not be this hard. I don't know if it just is, but like it feels like every time I'm like, let's just make like a simple OpenGL demo. I'm like, it'll be quick, right? 30 minutes. We'll have a little demo. And then it's like 2 hours later, and I'm like, fuck. I thought that was gonna be half an hour, which is why I knew that was gonna happen, which is why I did it in happy hour. But it's just like, I wish getting to this point was smoother. Um, we should probably just like change the color over time as well, huh? Like if we're trying to get something that we want to like render in the terminal and like prove that something's happening. Um, I kind of want like less strength from the sun. But actually maybe not. Maybe it's like more like I would just want it to be darker overall. And then I kind of feel like I want the sun more to like I want it like more to the right. So I want this to be positive, and then I want it like coming in at a I want it so that like my maybe I said I want like my Z component to be less strong. Maybe I want this. That kind of feels like maybe what I want is that I want it to be like just fully on the right or something. Sees. I lied again. I just want it to be like less like aggressively coming from like behind me, but maybe not this much. So maybe I want it like, maybe 0.5 here. Something like that. Those are nice numbers. Yeah, I feel like that's fine. I feel like that's fine. Um okay, yeah, let's change the color of the cube as it rotates as well, which should be easy. I guess to do like color rotation, you need like HSV to RGB. I guess. Which I'm just gonna Google. We've done this. We've done this one enough. We've beaten this dead horse. Uh. Okay. C or V is HSV2. I guess we only care about hue. Yeah, so this is just one, right? Saturation max. HSV is, do we want value? I can't remember what this guy looks like. Saturation, we want max saturation. Brightness, we want max brightness. Yeah, so it's literally just hue. So we just want these turn into one, which means that this turns into one. Uh, so this is just hue here. Hue to RGB. And now what's going on here? 1 minus absolute value of H over 60. Mod 2 minus 1. Jesus Christ. So 60 in degree or in radians. Do I want this in radians? I guess this could be in like fucking degrees. Who cares? Sure. Um, y mod 2 minus 1. H over 60. So this is going to tell me which quadrant. What, like 1 of 6? Mod 2 gives us this. Oh, mod 2 is floating point modulo. Sure. Sure. So this is going to be like a gradually changing thing. Yeah, okay, that makes sense. Sure. Mm, yeah. Okay. So does Zig have fmod? So I don't have to think about this. Zig mod f, like mod f32. Yeah, I guess that is what I want. No, I'm confused again because shouldn't this take 2 values? I guess I just divide by 2 and then times 2 after. Um, returns the integer and fractional floating point numbers that sum to x. Oh. Sure. Can I just like extract like decimal part of float? Is there like an intrinsic for that? Feels like there might be. I feel like zig lang ref. I feel like I've seen something like this, like rem remainder division for unsigned integers. Yeah, I guess that's not what I want. Does it start with an F in here? F something float. All right, maybe this is in the standard library. Because I feel like fmod is now not quite what I'm looking for. Like remainder returns the remainder when the numerator is divided. No, like fract mod f. Yeah, okay, maybe float fractional bits. Yeah, I guess it is what I want. We just want mod f. Okay, so we divide by 2. We take the fractional part and then we multiply by 2 at the end. Sure. Is remainder not what we want? I thought that it didn't work with floats. I thought that this only worked with integers. But maybe I'm a dumbass? Like for... Oh. Yeah, I don't know. My eyes looking at this like looks like integers. But I guess nowhere does it say. But I know that looking at like mod f, this guy's doing some like wacky shit. Oh, he's no, maybe he's not. Interesting. I'm not gonna think about it. There is due remainder to float. Yeah, it's okay. This is good enough. We'll live. Then we need to know like which quadrant I guess we're in, or which like segment. This is gonna be like int from float hue over 60. And now we're like doing something different depending on which segment we're in. So we're like, this formula, shut the fuck up. Not this one, this one. Did we lose it? Did we lose it? What the fuck? Yeah, so it's like if this is 0 to 60, we do this. So this is 1x 0, then x1, then shift right, then shift right again, but with wraparound. So this becomes x1 0 like this. I think that's what this says. Yeah, it looks about right. Sure. Sure. Alright. So now if we do somewhere, we probably in the fragment shader set the color. Are you done with the markdown rendering thingy? Yeah, I kind of like polished it off to the point where it had like emphasis in bold yesterday, kind of like last night at like 1 in the morning. And then I like hooked it up to the TV tracker and I was like, I don't want this. So I ended up just like scrapping the whole thing because I was like, you know what? Oh, it's not on right now. But like just having like the notes field as plain text was like, oh, that's like good enough. I'm like happy with that. So I don't know, like I was like, I did all that work and I was like, nah. Color. Okay, so now we set the color somewhere. Color uniform is color. And each frame, we set the color somewhere. GL uniform 3F? Hell yeah. And then we just pass in the thing. So we have like color uniform, and we say like RGB is hue to RGB of, you know, hue. We do like hue plus equals delta times something. Say we want like a full color change every 1 second. That becomes 360. We know we want to go slower than that, so let's go like 120. Okay. And then here we'll say, well, hue is greater than 360. Hue minus equals 360. Okay. Which allows us to do this. Then we get the RGB 0, RGB 1, RGB 2. Fuck. Why doesn't he like this? Oh. U32. That's fine. Adding percent 360 after the in from float hue might save us from the unreachable in the future. Adding percent 360 after the int from. What am I missing? Oh, sure. I see what you're saying. Because, like, if the thing gets out of range, this could happen. Yeah, that's a good point. Good point. Shader compilation failed because LG, thanks for this tier 1. Much appreciated. We forgot to write vec3 here, I guess. Okay, color's not changing. Not good, because we didn't actually use the color here. Okay, there we go. Looks like it's working. And then can we kind of dial back the speed? Sure. I mean, that's a good enough demo. Is your while loop decrement 360 until it's below 360 the same as modulus operation? I just don't know where the fucking modulus operation is. Like, can I do this? Is this legal in this language? Yeah, it's not, because it's like only integers and floats. I don't know. I might just be like fucking dumb as bricks. But I don't know where the fucking F, like where the mod F thing is. Like I feel like, man, mod F. Right, this is, maybe this also isn't what I want. Man, F mod? F mod. This is what I'm looking for, right? I know this function where it's like, give me two things and give me like, you know, the modulo part. But I feel like Zig doesn't have F mod. It said something about using grammar mod, huh? Did it? Signed integers and float must use. Oh. It does tell me exactly what I want, huh? I mean, if this works, then we're fucking chilling. When I looked at it, I was like, I don't feel like that's right. But it does seem like tools being good tools odd. Yeah, I can't read, okay? Reading's hard. We'll see what wraps back around to red. Yeah, I guess that's fine. Sure. Sure. Fuck it. Okay, so I know that the title said rendering 3D graphics in my terminal, and it's because I was planning on taking this example and feeding it through ncurses. But it's already 3 o'clock. It took us longer to make the demo case than I thought it would. So I think I postponed that till tomorrow. I guess we might as well post this on YouTube. So we'll pretend that this was like just a 3-hour normal stream. And then, do I want to do anything else today? I'm feeling a little lazy. So I think we call it there. I apologize for the bait and switch on the name. I really did think that we were going to get farther than we did. So I think we call it here. We'll be back tomorrow to do the actual text part of this project, which was where I wanted to go. But for now, that is all. So thanks for watching, guys. If you like what you saw, we stream most days. We shoot for around 12:30 Pacific time to 4 o'clock Pacific time. It's 3 o'clock Pacific time now because I'm feeling lazy. So anywhere between 2.5 hours ago and an hour from now is when you should expect to see us live. If you want to keep up, there is a YouTube link in the Twitch description where typically, where the main segment of this stream goes up. This will probably end up over there, but sometimes there's also like this like 12:32 segment that we call happy hour, which is kind of just like stuff that I don't feel like will hit the YouTube algorithm because, I can't title it and thumbnail it appropriately, or it's like not interesting, but it's stuff that I still want to work on and stream. So if you want access to those VODs, either you have to like catch it live on Twitch, like you're watching like now, or if you feel inclined, you can support on Patreon, Twitch, or YouTube, and VODs of those will show up in the appropriate places. Keep in mind that this content will end at some point when I need to like pay rent. But if you guys contribute and get access to these happy hour VODs, that time will be farther in the future. So just throwing that out there. Thanks for watching. YouTube, peace out. Twitch, let's find someone to raid.